So now all the hard work's done. Let's now do our drawings. We need to, first up, make a general assembly drawing showing an elevation. So we need one of those. Please copy that to here, from the center to here. Here will do. Okay. Okay, we need to now draw a sheave that is completely hidden by the plate. Let's have a look. In here on the center, I've got diameter 112. So that's diameter 112. Then we have got diameter 200, diameter 250 and 310. And diameter, done. So there's the sheave drawn in. Try that again. There's the sheave drawn in side elevation. That's already in place. Later on I'll come back and clean that up. We've got to draw a few nuts. Now we've actually already drawn these things over here. The swivel block was 100 by 100. So I'm just going to copy and paste this part. Once again, probably hidden. Move. Make a copy to there. And smack bang in the middle. There you go, that's what's visible. Okay, done. Let's get our hook, complete with removed sections. Copy that. And yes, we are making a copy. I don't know if I need the locator, so I'll just leave it up just in case. Done. Later on I'll move that sectional view out of the way so it's not clashing. Now, while I'm at it, let's just take a bearing. Why am I not worrying about things overlapping? Because later on I can just go hide everything and all I've got left is the hook. This I'm going to move to the sheave. So later on I can just select what I need and move what I need later on. Layers, show everything back again now. Take a bearing, copy the bearing from underneath. Okay, I'm going to move that one. There. There's the bearing in place. That's a 6mm deep recess, I think. Yep. There's the bearing. That should be 10. Yep, that's 10. And that distance from there to there is 8. That's exactly as per drawing. So there's a 28mm, that bearing acts as a 28mm shim, which it is. Nut, I'm just looking, is 26mm down, which means there's a 2mm gap in there. Show only. Let's just select our entire hook. Copy the center of that. Show everything. The hook must be physically buried up inside the taper pin like so. Oh, fiddlesticks. Let me go again. Now, I'm going to hit stop there for a sec. I'm going to go to the nut. draw the centre line back in on that. Done. Now I've got a mark to aim at. Now I only want to see the hook. Select everything. Move it from the centre of that to layers. To the centre of that. That is where the crane hook sits when it's in position. And then of course everything else is hidden. So let's now just start deleting everything that needs deleting. I'm going to hit save before I do, just in case. This here, minus that, I'll just move out a bit. Done. Now all that's left is we just need to draw in 5 nuts. And I said with washers as well. So drawing the washers is easy. They are double diameter. That and there's a 12mm bolt, so that is 24mm. Done. 1, 2, 3. Done. So there's our washers. That's a 50mm washer hanging off the swivel block. So let's just put in our 50mm washer. And the sheave pin is a M20, so it's a 40mm diameter circle. That there is now, we're looking at the end of a bolt, was M12 by 1.75. So let's offset this. No, actually I'll just draw it straight out. I'll draw an arc by a centre point. There is the centre point. 12 minus 1.75 is, I'll need a radius, is 10.25. Half of that is 5.125. Starts there and it finishes there. And it is lightweight. Done. That indicates an internal thread because we're looking at the outside of a nut now. So let's just copy that from the centre mark across to his other two mates. Done. We have got there, I'm looking at the end of the swivel block, M20 by 2.5 from memory. Yep. So coming down in here, I'm going to do exactly the same thing. M20 by 2.5, that's 17.5. Half of 17.5 is 8.75. It starts there and it finishes there. And that is a 25.5 circle, but I actually want an M20 bolt. I don't want the hole that's fitting through. Okay. Yep, M20 hex nut. Up here the swivel as well. It's exactly the same thing. It's an M20 nut up the top. So let me just copy that. And paste that. Done. I'll only work here in detail on this one, then I'll just copy and paste for the rest. The size of the bolt is 1.8 diameters. 1.8 times 20 is 36 mil. Let me now just draw in the flats. That's at 60 degrees. Minus 150. That's there. That's straight down. That goes to the quadrant point. That one's 30. That one comes up. And that one there is nice and neat. Okay. So there's our bolt head drawn, looking at it from on top. Then we just put in a circle, just touching the outside of the flats. There you go. There's our bolt head drawn. Now, I'm going to copy that one and paste that bolt head, then I'm coming back to this. I'm going to copy that from there to up the top, had an M20 bolt on it as well. And I'm going to drop that there. Now I'm going to rescale it from 12 divided by 20. And that is now an M12 bolt head. This is the advantage of CAD. It saves you drawing things multiple times. You can copy and paste. There it goes. So there's one M12 bolt head. There's 2. There's 3. And there's the one I want to delete. Oh. So there's the bolt heads all drawn. Also, for one thing, you'll notice this has got a split pin coming through it. A split pin that's been sitting here on the screen for about 24 hours till I had a chance to show you what they are. That is a split pin. See the front view, side view? You've seen them. I think Americans call them cotter pins. If I come here and go split pin, draw to AS 1100. There we go. That's how they're drawn. You can see that. Here is the way I was trained. If it shows up, 3, split pin, that's how I was taught, a simplified drawing. And look at that, it's exactly the same as what we are doing for washers. So we'll just put a circle through it with a couple of legs. Perfectly okay. If you really feel as though you want to take time, you're welcome to draw it properly. So in here we have got a diameter 5 split pin. So let's just use this. Diameter 5, that's the size of the hole. Actually, I will draw it in. I'll draw in a proper one. It's going to be just as quick and just as easy. Or else you've just got a line there, you've just got to thicken up and do. I'll show you both. You decide which way you want to go. From here, I'll just put one out at an angle. Put this one out longer. Match that angle. Clean that up while I'm here so I don't need to zoom in again. So there's that end of it. Over this end, Actually, I forgot one thing. Let's just put in that curve there, from there to there. Draw that line out here. I've got to draw it with the just bring that so it's tangent. I've got to draw this with the pin bent to indicate that it's a cotter pin or a split pin. That's the point of tangency. And which way did the angle go? Pitch back like that. I don't mind which one of these you do. You can do either or. Later on I'll remove that circle. Almost like beats, but the sign's back to front, isn't it? Done. So there's our split pin at that end. At this end, we'll just pick a mark, pick something that looks about right. Yep, that'll do me. And we'll just insert a couple of rounds once again that look about appropriate. When I get the two right components. And delete and trim. And trim. And in here, obviously that's not visible because that's inside the nut. That'll do us. So that's our split pin indicated. There's our front elevation finished.